Hello my dear student, welcome to another video of the channel MALACHEMPHILIC, and this is video number 141, which is the 80th episode of Chemical Thermodynamics course, and the topic of this video is Thermochemistry part 6. So let's see what is there in part 6 of Thermochemistry. Already I have shown you this content of thermochemistry where enthalpy of reaction, enthalpy of formation, enthalpy of combustion, enthalpy of transition, enthalpy of phase change, enthalpy of neutralization, enthalpy of hydration and enthalpy of solution I have completed in my earlier videos. So today's topic, that means the topic of thermochemistry part 6 is bond enthalpy. So let's start. Bond enthalpy. By definition, it is the energy required to break 1 mole of the bonds in the gaseous phase to separate the atoms. Say this hydrogen-hydrogen bond is broken from hydrogen molecule and 2 hydrogen atoms are formed. That is in gaseous phase. And units of bond enthalpy is kilojoules per mole, and it is always positive, that means endothermic, because to break the bond you need to supply the energy. And higher the bond enthalpy, stronger the bond, or if the bond is stronger, bond enthalpy will be higher. Now, often we define this average bond enthalpy, that is average energy required to break 1 mole of the bonds into atoms. That means 1 mole of the bond means same bond, say a number of same bond present in the molecule. Say for example methane. Methane, there are 4 carbon-hydrogen bond. If you break 1 carbon-hydrogen bond, then CH3 and hydrogen is formed. That is methyl and hydrogen is formed. Then from CH3, if you break another bond, then CH2 another hydrogen. In that case, for each carbon-hydrogen bond enthalpy may slightly vary. So here we'll take the average of all 4 bond enthalpy of carbon-hydrogen bonds in methane. Say here it is, this CH4, then it is broken to CH3 hydrogen, okay, and then C bond enthalpy is X1. Then again CH3 methyl, then CH2 gas plus hydrogen atom, then X2, this bond enthalpy. Then CH2 again it is broken to CH and hydrogen, that is X3, that is bond enthalpy. Then CH is broken to carbon and hydrogen finally. So in that case all are CH bond, but X1, X2, X3, X4 slightly vary, not exactly same. In that case we'll take the average of all 4 carbon hydrogen bonds in methane. Now, calculation of reaction enthalpy from these bond enthalpies. Okay, reaction enthalpy is equal to, remember this formula, summation of bond enthalpies of the bonds broken, that means the reactant, in the reactant bonds only broken, minus summation of bond enthalpies of bonds formed, that means the bonds formed in the product. Now, bond breaking, already I told you, it requires energy. So it is endothermic and its value is definitely positive, right? And bond forming is exothermic, where energy is released. So the formula of this enthalpy of reaction is summation of the bond enthalpy of the bond broken minus bond enthalpy of bonds formed. Now, let's see this one. You have to find out the expression of the enthalpy of reaction of this reaction. What is this reaction? Nitrogen, hydrogen giving the ammonia, right? So, just now we have seen this formula. 1 minute. So, this this reaction enthalpy, this is per mole. So, delta H0 of this reaction, that will be is equal to what? That is equal to summation of bonds broken. That means this is for reactants. Minus summation of bonds formed. So bond form means this is for the products, right? This is for the products. This is the formula. So here we'll write, so delta H0 of this reaction, that will be is equal to, what are the bonds broken? Half of nitrogen bond, right? Plus 3/2. Here I'll write, let me write bond enthalpy, half bond enthalpy of this nitrogen bond, okay, plus 3/2 bond enthalpy of what? This hydrogen bond, okay, then minus, how many nitrogen bonds are there? 3. So 3 bond enthalpy of this nitrogen bond. So this is the expression of this enthalpy of reaction for this particular reaction in terms of bond enthalpies. Now coming to this problem. Methane and chlorine giving dichloromethane and hydrogen chloride, and here given carbon hydrogen bond enthalpy 414 kilojoules per mole, chlorine bond enthalpy 243 kilojoules per mole, carbon chlorine 331 kilojoules per mole, hydrogen chlorine 432 kilojoules per mole. What you have to calculate? That is the enthalpy of the reaction, right? So we know, just now we have seen the formula, delta H0 of the reaction, that is the summation of the bonds, that means summation of the bond enthalpies or bonds broken. So bonds broken, energy of the bonds broken, so it is reactants minus summation of the enthalpies of the bond forms. So I am writing in short, bond formed. That means it is product. Already we have seen this one. Now put the values. So here delta H naught of reaction, that will be is equal to, there are 4 carbon hydrogen bond, so 4 carbon hydrogen plus 2 chlorine bond in the reactant side plus 2 chlorine bond, right? So this reactant part is over. Minus, what is there? Look at here, 2 carbon hydrogen bonds. So 2 in carbon hydrogen bonds, right? Then 2 carbon chlorine bonds. So plus 2 carbon chlorine bonds, right? Then 2 hydrogen chlorine bonds, that means plus 2 hydrogen chlorine bonds. Bonds in that sense, I am telling about bond enthalpy of hydrogen chlorine, right? So this is the things. Now we'll put the values. So here 4 into carbon hydrogen bond enthalpy value is 414. 414. 14, right? Plus chlorine value is how much it is? 243. So 2 into 243. 2 into 243, all are kilojoules per mole, right? Then minus carbon hydrogen value is 414. So 2 into 414. Then carbon chlorine, that value is 331. That means plus 2 into 331. And then hydrogen chlorine, that value is 432. So 2 into 432. Okay, so these are the values. Now we'll do this calculation. Here it is coming as 1 minute. Here it is how much? 4 fourths are 16, 5, 4 fourths are 16 plus 6, 8, then 2 twos are 4 minus, here it is, then 8, 2 fours are 8, 2, then again 8, then plus 2, 6, 3 twos are 6, 3 twos are 6, plus 4, 3 twos are 6, then 8, 4 twos are 8. So this value will be 2142, and this, if you add it, this value is minus 2354. 2354. So the answer is minus 212 kilojoules per mole. This is the answer. Okay. Now, second problem. What is the problem? This is ethylene or ethene plus hydrogen. That means hydrogenation. And the product formed is ethane hydrogenation reaction. Given bond enthalpy of carbon-carbon single bond is given. Okay. Then bond enthalpy of carbon-hydrogen bond is given. Bond enthalpy of hydrogen-hydrogen bond is given. And the enthalpy of the reaction is given. And what you have to calculate? The bond enthalpy of carbon-carbon double bond. Okay. As it is, as we know that delta H naught of reaction, that will be is equal to your summation of bond broken. That means bond enthalpies of the reactant minus bond enthalpies of the product. Okay. So directly I am writing, or first we'll write, okay, this is bonds broken, energy of these bonds broken minus summation of energy of these bonds. Energy means enthalpy of the bonds formed. Okay. Now put the value. What is the enthalpy of the reaction value? That value is minus 124 kilojoules per mole. Now here we will put the values. What are the bond broken? One carbon-carbon double bond is broken. That bond enthalpy you have to calculate. So carbon-carbon double bond 1 plus 4 carbon-hydrogen bond, 4 carbon-hydrogen bonds are broken, right? plus one hydrogen bond has been broken. That is one hydrogen bond minus, what are the bonds formed? Bonds forms are one carbon-carbon bond is formed, carbon-carbon single bond is formed, plus 6 carbon hydrogen. Ethane means 6 carbon hydrogen bonds are formed. So this one, right? So minus 124, that will be is equal to this. You have to calculate, that is the bond enthalpy of carbon-carbon double bond, right? So now 4 into carbon hydrogen bond is 413 plus 4 into 413 plus hydrogen bond enthalpy value is 436. 436 minus carbon value is 348 kilojoules per mole plus 6 into, once again this carbon hydrogen bond, that means 413. 6 into 413. These are the values, right? So minus 124, that is equal to this bond enthalpy of carbon-carbon double bond, right? Plus how much it is? 5, 4 4s are 16. Okay, 1652 plus 436 minus 348. Then how much it is? Plus 18, 7, 4 6 are 24. This is the value. Okay. So minus 124 is equal to this carbon-carbon double bond enthalpy plus, if you add it, then it will be 2088. 2088 minus 6 to 2826. 2826. 2826. Right? So this bond enthalpy of carbon-carbon double bond, that will be is equal to, how much that will be? Minus 124 minus 2088 and then plus 2826. So this value will come 614 kilojoules per mole. So 614 kilojoules per mole is the bond enthalpy of carbon-carbon double bond. Okay. So hope it is clear to all. Thank you.